If you look at the technology shaping our world right now, you'll see software that can navigate busy intersections at night, systems that can filter through billions of emails in seconds, and algorithms that can predict exactly what you want to watch next. Open any tech blog, read a press release, or an earnings report, and you will see all of these distinct tools grouped under one massive umbrella: artificial intelligence. But right next to it, you'll often see a second term deployed in the exact same conversations: machine learning. Because they appear side by side so frequently, it is incredibly common to assume these two phrases are just synonyms for the same digital process. When we use these terms interchangeably, we lose sight of the mechanics. We stop seeing how the software is built, which makes it harder to identify why it makes the mistakes it does. To understand what modern tech is doing, we have to pop the hood and look at the components separately. This schematic outlines the core problem. Confusing artificial intelligence and machine learning is like confusing a vehicle's destination with the physical engine doing the driving. Our goal here is to split the broad concept of intelligence away from the specific mathematical process of learning. Making this distinction allows us to move past the hype and look at the actual logic powering the system. Let's start with artificial intelligence. AI is the overarching goal of computer science. That goal is to create systems capable of simulating human thought. We want machines that can weigh options, make independent decisions, and solve complex problems on their own. Early basic forms of artificial intelligence relied entirely on rigid logic. Human programmers had to write out every single rule, line by line, telling the machine exactly what to do in every conceivable scenario. A system built like that cannot adapt when it faces a situation the programmer didn't anticipate, and it has no mechanism to improve its own performance over time. AI on its own, without a mechanism for continuous learning, is a rigid vessel. It hits a hard technological limit the moment it encounters the messy reality of the real world. That is the exact problem machine learning was created to solve. Machine learning is a specific, practical subset of AI. It uses statistical algorithms, sets of mathematical instructions, to identify patterns, completely bypassing the need for explicit manual programming. As this animation shows, the programming approach is inverted. Instead of writing out logic rules, engineers feed the software massive streams of disorganized data, and the algorithm sorts out the patterns by itself. Machine learning acts as the dynamic engine. It takes that rigid vessel of basic AI and transforms it into an adaptive system capable of genuine self-improvement. To see how these two pieces interact in practice, let's look at this wireframe visualization of an autonomous car approaching a four-way intersection in the rain. Before this vehicle ever hit the pavement, it ingested millions of hours of driving footage. Its algorithms mapped what hazards look like through heavy rain, glare, and darkness to locate shapes like this obscured stop sign. That probability meter climbing to 99.9% is the machine learning component doing the heavy lifting. It functions as the vehicle's memory and pattern recognition center. But recognizing a sign isn't the same as driving. The real-time, human-like decision to act on that data, sending the command to the brakes to stop the car at the line, that is the artificial intelligence in action. As the car drives, the system runs a continuous loop. It collects fresh road data, applies its ML algorithms, learns new patterns, and outputs a smarter AI decision. The vehicle stops safely because the engine identified the pattern in the data and generated the correct response. The intelligence here is the direct result of that learning process. Zooming out from the street level, that continuous loop dictates the structure of modern computer science. This diagram outlines the rule governing the space. All machine learning is artificial intelligence, but not the reverse. AI is the outermost umbrella. Machine learning sits inside it as the functional technique. One layer deeper is deep learning, handling even more complex data. Because of this strict hierarchy, attempting to build a modern, adaptive AI system without using machine learning is practically useless. We are rapidly approaching a future heavily reliant on these systems, trusting them to output highly advanced healthcare diagnostics and tailor personalized education programs for students. Those future systems will not automatically improve on their own through sheer computing power. Every leap forward in capability is entirely dependent on what we feed the machine. We have to input better, highly diverse, and strictly unbiased data into the underlying learning algorithms. Artificial intelligence represents the grand vision of a fully autonomous, intelligent machine. AI sets the destination on the map, but machine learning is the engine that will actually drive us there.